This is a class on entrance exam solutions on wave optics, and the specific point is polarizations. And this chapter, the solution of this chapter is completely based on the previous conceptual class polarization. Otherwise, you will not able to understand it clearly. So, first of all, let us take first example. Light wave can be polarized as they are. Light wave can be polarized, but sound wave cannot be polarized, because light wave is transverse in nature and sound wave is longitudinal in nature. So the wave which are longitudinal in nature cannot be polarized. So since light wave is transverse in nature, hence light wave can be polarized. So first answer is over. The next question is, through which character we can distinguish the light waves from the sound waves? TT polarization. Answer once again the same. Light wave can be polarized, but sound waves cannot be polarized, because sound wave is longitudinal and light wave is transverse. Only transverse wave can be polarized. The angle of incidence at which reflected light is totally polarized from air to glass. The refractive index of glass or the material upon which light is incident is n, here given. And you are asked the angle of incidence at which reflected light is totally polarized. So in our previous class we have seen that if you say it is glass slab, so we discussed it in last class that when light is fall upon the glass slab, so it is reflected and it is also refracted. So this is angle of refraction and this is angle of incidence, means theta p. So this is the angle of polarization, at which angle, if it is the angle, if light is fall upon this glass, it will be totally reflected. That angle is theta p. So if it is theta p, then it is also theta p. Then theta p and theta r is equal to 90. Means this angle must be equal to 19 by last class I have told you. So it is told, and here that was used in Brewster equation, mu is equal to 10 theta p, where theta p is angle of polarization. You are asked simply the angle of incidence at which reflected light is totally polarized. It is the angle of for such angle it is totally reflected. It is totally reflected, light is totally polarized. Then according to Brewster equation, mu is equal to 10 theta p. Now mu is equal to 10 theta p by Brewster's equation, BRESWS, Brewster equation. And here you are asked the refractive index equal to n. So in place of mu you put n is equal to 10 theta p. Then 10 theta p is equal to 10 inverse n. It is very simple. Question was asked in lot of entrance exam. A double P upset and BI T double E Jammu Kashmir. Now next one, which of the following cannot be polarized? Very simple. Radio waves, UV waves, UV rays, IR rays, ultrasonic waves. All these waves are transversal. These are transverse in nature. So transverse waves are polarized, and you are asked which of the following cannot be polarized. Also ultrasonic waves and sound waves. Sound wave is a type of sound. Ultrasonic waves, these are longitudinal wave. So longitudinal wave cannot be polarized. So your answer is ultrasonic waves. This question was asked in entrance exam. A polarized light is placed at 45 degree to an incoming light of incidence I naught. Now the intensity of light passing through the polaroid after polarization is, means the initially unpolarized light was like this, and it is made to pass through this polaroid. Say this is a polaroid, and you are asked after passing through polaroid the light was made plane polarized, and you are asked before polarization intensity was I naught, and after polarization intensity was I. So you are asked, a Polaroid is placed at angle 40 and that Polaroid, so I have is put it in vertical way, and here they have I is equal to I naught cos square theta, and you are given the angle is equal to this. So you are asked to find out the intensity after passing through the polarization of Polaroid. So answer is it will be half of the initial intensity if the Polaroid is at 45 degree centigrade. Next question, a beam of natural light falls on a system of 5 Polaroid which are arranged on succession such that the path axis of each Polaroid is turned through 60 degree with respect of previous one. The fraction of the incident light intensity that passes through the system is, that question was asked 2011. So say these are the unpolarized light. Very simple, not tough. I will show you the technique. You are asked that a beam of natural light is made to pass through in this way. This is Polaroid P1, P2, P3, P4, P5, 5 systems of Polaroid which are arranged in succession, that is one after another, and pass axis of each Polaroid is turned through the 60 degree with respect to the one. If it is 60, that another previous is also with respect of this Polaroid it is 60, with respect of this it is 60, with respect of this it is 60, with respect of this it is 60. Am I right? So these are placed in this way. You are asked what is the intensity of final polarized light. So first of all, if I assume it I naught, so this is one P1. For P1, the intensity of plane polarized light I is equal to I naught by 2. I have told you in the previous class. So now for P2, say for this one I1, this is I2, this is I3, this is I4, this is I5. For Polaroid P2, the I2 is equal to I naught into cos square theta. This is the formula of Malus equation. I is equal to I naught cos square theta. So if you assume this one, so intensity of this one will be half of the initial one. So here intensity of second Polaroid after passing through second Polaroid, here the intensity of this plane polarized light is equal to I naught cos of theta, initial intensity into cos square theta. What is initial intensity? Initial intensity is equal to I naught by 2. And what is angle of theta? And you are asked, it is 60. And if you cos 60 is equal to half, half means 4, 1 by 2 is equal to 1 by 2 means 1 by 4 is equal to I naught by 8. So let us come to the second one, third one, I3. Again that will be equal to I naught cos square theta. What is I naught? I naught is equal to half of 2 and cos square theta, and that one will be this, because I3 is equal to I2 into cos square theta. And what is I2? I2 is equal to I naught by 8, and cos square theta again half, 60 degree, 1 by 4. 1 by 4 is equal to I naught by 32. Again I4 is equal to I3 cos square theta. What is I3? I3 is equal to I naught by 32. Again cos square 60 is equal to 1 by 4 is equal to I naught by this. And at the last, what is I5? I phi is equal to I4 into cos square theta. What is I4? I4 is equal to I naught by 128 into again 1 4. This is equal to 1 by I naught by 512. This is the answer. What will be the intensity of the light after passing through the final Polaroid? Answer I naught initial divided by 520. Now you may think that for this we have to do a lot of things. No, you need not to do. But trick or technique I am going to explain you. Here you see, just you see, this is from Malus equation. We know that for first Polaroid the intensity is half of the incident light. It is known to us, it is given by Malus. We have already explained in the last class. Again, for this is for I1. So for I2 what we get here is equal to I naught by 8. You can do it mentally. Mental calculation is required because here cos square theta means half means 1 by 4. Here I naught by 2 and 1 by 4, 1 by 8. So you are getting mental calculation 1 by 8. So out of these two, how much you are getting? It is multiple of the denominator is multiplied by 4. Am I right? So next one will be I naught is equal to 32 and next one equal to again it is multiple of 4. Again next one is multiple of 4. Need not to do all the sum. You first take out first two and see the relation of denominator. Whatever term is to multiply to get the next term, you multiply. This is 1, this is 2, this is 3, this is 4, this is 5. You are getting 5. If it is 45, angle is 45. So 1 by root 2 means half. So you are getting half means you are getting not 1 by 4, 2 multiple. So it is half, then will be 4 multiple of 2. If it is 45 angle, then your first one is same I naught by 2. If it is 45, then second one is cos 45 is equal to half. So this is there, this is multiplied by half means I naught by 4. So what is the relation of these two? You are multiplying each term by 2, not by 4. So next one is equal to I naught by 8, next one equal to I naught by 16, next one equal to I naught by 32. Had the angle be of the arrangement of the Polaroid is 45. So whenever you see the angle, you mentally calculate no matter what lengthy question is. No need to read, you go on doing the sum mentally. This is the trick. Next question is, the Brewster angle for the glass to air surface is 5474. If a ray of light going from air to glass strikes at an angle of incidence 45, then angle of refraction is, what is Brewster angle? The question was asked in JNK CAT a lot in entrance exam. So you see the Brewster equation is tan theta p. You are asked the angle when light fall upon the glass interface, the angle is 54. So what you get here is tan 54 into 74. But the fact is that you were asked angle of refraction. So there is no connection of angle of refraction. But you now there is no way you are asked to find the refraction. So how mu is related? Mu is related by Snell's law, sin I by sin R. So here you see you are asked if the ray of light going from air to glass strikes at an angle 45. Ray of light incident ray makes an angle 45. This is the question. Am I right? So the Brewster angle means theta p. Brewster angle means theta p. Theta p is given 54 into 74. Am I right? And you are asked the light is made to fall upon the glass at an angle 45. What is the angle of refraction? So sin I by sin R is equal to tan of this, that sin I 45 equal to 1 by root 2. That is you are right. 1 by root 2 is equal to sin I, and this is equal to root 2. You are given in the question. Tan of 5475 is equal to root 2. So on solving this, you will find sin theta is equal to 1 by root 2 into 1 by root 2 is equal to half is equal to sine of 30. Therefore sin theta means it is r, therefore r is equal to 30 degree. Very simple, just you think the question is within a second you can solve out the question. Yes, the next part, again the question number 8. When unpolarized light is incident from air to glass at polarizing angle, if the light is made to fall on the light or the media, say it is a glass, so if angle is polarizing angle, then the reflected light or beam will be 100%. So your answer is, the answer is reflected beam is 100% polarized. Out of the option I have given, I have not written the options. In the options a lot of things are given. So the reflected beam is 100% polarized if the light is fall on the mirror, or sorry, on glass at angle of polarization. The question was asked in entrance exam. So next question is, the transverse nature of light is shown by, at the very beginning I have already mentioned, and the question was asked in lot of entrance exam. You read it out, it is very important. It is the transverse nature of light is proved by the fact that light can be polarized, that polarization is shown. So next, when the angle of incidence on a material is 60 degree, the reflected light is completely polarized. The velocity of reflected light, what is the Brewster equation? Brewster equation is mu is equal to tan of theta. This chapter is completely based on Brewster equation, and another is I is equal to minus Malus equation. Out of this we will solve each one. So mu is equal to tan of theta p. You are asked, when the angle of incidence on a material is 60 degree, the reflected light is completely polarized. Means this is angular polarization. The velocity of reflected light is inside the material is, so here you are given this is 60 degree, am I right? And this much you can do. Now you are asked the velocity of refracted light. So mechanism, once again I am showing you, it is a glass material, light is fall upon this one, and if you draw normal, it will be reflected. This is theta p, and this is reflected light, and this is reflected polarized light. Am I right? So theta p, when light is made to incident upon this material, glass material, so at angle of polarization 60 degree, it is reflected completely. And you are asked the velocity of reflected light inside the material. Now some light has come through this one inside the material, imagine this is reflected. Now what is the velocity of light inside the material? It is reflected, comes out, and what light has refracted inside the glass material, you are asked to find out the velocity of that material. So don't be confused and don't be nervous. So what is mu? Mu is equal to velocity of light. In class 10 also you have got this, velocity of light in air divided by velocity of light in the medium, that is velocity of light in air divided velocity in the glass media, say, and tan of 30 is equal to root of 3, 1 by root 3. So very simple calculation, you see, Vg is equal to c by root 3, and velocity of light is equal to this much, you know, this much, is not it? So in place of 3 we can write root 3 into root 3, just to cancel sorts, you are getting 1 root 3 here, √3 into 10 to the power 8 meter per second. So velocity of light inside the material is equal to this much. Thus only to correlate where from you will get the velocity of light in the media, that should be velocity of mu is equal to velocity of light in air or vacuum divided by velocity of light in the medium, and you find out the velocity of light in the medium by simply by using the data. This question, a light has amplitude A. Whenever you asked amplitude, Malus equation, you let me write Malus equation. Malus equation is equal to I is equal to I naught cos square theta, and since I is proportional to amplitude square, so we can write A square is equal to A naught square equal to cos square theta. Removing all square, A is equal to A naught cos of theta. So with the help of amplitude we get the result. So we need this equation. So a light has amplitude A, angle between the polarizer and analyzer. This is the normal light, am I right? This is going to fall upon, say this is first polarizer, am I right? This is analyzer. So angle between polarizer and analyzer is what? 60 degree. The light, after this you are getting this, am I right? The light reflected by the analyzer, after analyzer light has gone out, am I right, has amplitude. What is the amplitude? So what is the relation? A is equal to A naught cos of theta. So A is equal to A naught cos theta means 60 is equal to half. The question seems to be tricky one, but when you start doing the sum, it is very simple. So amplitude will be the half of the initial one. This is the answer. Now the question number 11, theta p for water is equal to 53. So angular polarization for water is this much, you keep it in your mind, and angular polarization for glass is 57.4. For glass it is 57.4, for water is 53.4. Mind that. So theta p for water is equal to 53.4 if the light incident at this angle on water and refracted. What is the angle of refraction? So this is very simple thing. That is light reflected, total reflected light, polarized light. Am I right? So earlier I told you either this angle is equal to 90 or theta p plus theta r is equal to always 90. This plus this 90 or this is equal to this, theta p means theta p and theta r is equal to 90. If these two are 90, automatically this is 90. Simple mathematics. So we know theta p plus theta r is equal to 90, and you are asked for angle theta p is equal to what? 53. You just put here 53. What is angular reflection? Then theta r is equal to 90 minus how much? 53.4 minutes. So your answer will be 90.0030. You can calculate yourself. This is the answer. Very simple. Just to keep it in your mind, this relation. Am I right? This is the answer. Question number 2 is, unpolarized light falls on the polarizer P and then analyzer A, and the intensity transmitted light from the analyzer is 1/8 of the intensity. I am drawing, you can very easily understand. This is unpolarized light. It is made to fall on polarizer. Say this is first polarizer or polarizer, and this is polarized light. This is I naught, this is I. So what is Malus law? Malus law is I is equal to I naught cos square theta. Theta is here, you are asked, theta is 60. It is polarizer and it is analyzer. The angle between these two, sorry, you are not given. Unpolarized light, unpolarized, that is P and analyzer A. This is polarizer, this is analyzer. Intensity after transmitted light from the analyzer 1/8 of the incident light unpolarized. Yes, you are not given. This is not given. Thus theta is the angle between polarizer and analyzer. You are asked to find out the optic axis between P and A, polarizer and analyzer. So actually from Malus law we have already known that I is equal to I naught by 2, and here cos square theta. And you are asked, you are told that transmitted light, when the light has already been transmitted from what? From analyzer. After passing through analyzer, light is transmitted this analyzer is 1/8 of the incident unpolarized light. It is 1/8 of unpolarized light. So this is 1/8 of unpolarized light. Am I right? So what you get here is, so angle between A and P is 60 degree. Again, it is very simple. Just you put the value. So here the question is, you see, first two beams A and B, beams of light A and B of the plane polarized light, beam of plane polarized lights with mutually perpendicular. One is mutually perpendicular upon another, are seen through a polaroid. From the position when A has a maximum intensity, then B is equal to 0. A rotation of polaroid through 30 degree makes two beams appear equally bright. If the initial intensity of two beams are IA and IB, what is the relation between IA by IB? Means one polaroid is this, say this is P1, and other polaroid is here, say it is P2. One is perpendicular to other. You are asked, you are told they are mutually perpendicular. When seen through a polaroid from the position when A has maximum, so the beam A has maximum intensity, then beam B is 0. A rotation of polaroid through 1. So you have viewed light through this polaroid. It is polarizing and another is analyzer. Polarizer, analyzer. So through the polarizer, when you view, say that angle is theta, and since these two are perpendicular, then this angle is equal to 90 minus. You are asked if the angle when it is viewed through a polaroid and the rotation is made through angle 30, means that angle is given 30, then that angle is equal to 60, because P1 and P2 are perpendicular. So you are make this angle here, means that polaroid, as if it is 30, then other will be 60. If it is theta, other is 90 minus theta. This is the situation, diagrammatic situation of the statement. Now you are asked what is the formula. The formula is I is Malus equation, I is equal to I naught cos square of, with respect of 1 you are getting, say IA one is IA So out of this relation we can write, one is intensity for one beam IA, that is at 30. So for IB it will be 60. So from one relation IA cos square 30, and from another relation IB cos square 30. So two beam, for two beam, to this one rotation of polarizer for beam A is made through 30 degree centigrade. For the beam B it will be 60 degree. Am I right? So because this P1 and P2 are perpendicular to each other, so we have got two relation. According to question, there it appears equally bright. That is, we can write IA cos square 30 is equal to IB cos square 60. So IA by IB is equal to cos square 13 cos square 60, that is half equal to 1 by 4 and root 3 by 2 whole square. So what we get here is 1 by 4 into 4 by 3 is equal to 1 by 3. So IA and IB ratio is equal to 1 by 3. This is all about of today's class. Thanks a lot for watching the class. Hope you have find the class interesting. And in the next class, I will again choose another interesting topic. And please don't forget to subscribe the class to remain updated, to get the updated information.